All right. Yeah. So we had a meeting today at 9, from 9 onwards. That was some document verification meeting, but uh, you know uh, it was not mandatory, so they permitted me that I can do the class. So fine. Otherwise, it will be a real problem, if we keep missing classes. All right. So we were discussing about master method yesterday, and we had taken up this problem, right? So all of you are aware of master method. So we discussed yesterday. There are three rules that are applied under master method, and we had solved this problem yesterday, right? So after doing some problems, okay, maybe tomorrow, okay, so we'll be doing some more problems today, and then we will again do some problems with the all the methods that we have discussed, that is recursion tree method and substitution method, that is also called as guess and test method, and master method. Then we will be discussing tomorrow the proof of master method. Maybe you would have done that previously also. Okay, so we must know, why these three rules are there. Okay, it's very nicely given in our textbook. Okay, so the theorem also has been taken from the textbook, and the author also follows the same thing. He gives the proof after some problems. Okay, so we will see that proof why it is so tomorrow. Okay, so it's nothing but which term is dominating at a particular condition, so that becomes the complexity of the function. All right, so let us do this problem we had done yesterday. So let us take another problem. Okay, this one, right? So Tn is Tn by 2 plus 2 to the power of n. The rule is again given here, right? So now the most important part is we find out what is log A base B. Okay, so quickly, can you please tell me which case it is going to fall? You need to take a pen and paper, students, those who were absent yesterday. So this is the master method, and what we need to do is, it depends on what is Fn, right? So the it is given in the form of Tn is equal to Atn by B plus Fn. So here A is 1, Atn by B is 2, and Fn is 2 to the power of n. And then we find out that Fn is of which form, whether Fn is O, n to the power log A base B minus epsilon, or it is omega n to the power log A base B plus epsilon, or it is theta n to the power log A base B. So depending on that, we have the time complexity. So please do this. So you need to find out what is A, what is B, what is Fn, that is already given. Then you need to find out whether Fn is falling in which case 1, case 2, or case 3. Accordingly, we can find out the complexity. So one of you have to tell me which case it is going to fall.
Third one.
It will fall in case 3. Okay, let us see. Hmm? So here A is 1 because it is A T n by B. B is 2, right? And then Fn is 2 to the power of n. That is what is given. We need to find out n to the power of log A base B, right? So n to the power of log 1 base 2. Log 1 in any base is 0. So it is nothing but n to the power of 0, right? So now my Fn is n to the power of 0. So I can, sorry, this is n to the power of log A base B is n to the power 0. And my Fn is 2 to the power of n. Right? So I need to ask three questions: whether Fn is O of n, whether Fn is theta of n, or whether Fn is omega of n. Obviously, it is going to fall in case 3, right? So the question is whether 2 to the power n is O, n to the power of 0 minus epsilon, where epsilon should be greater than 0, or whether it is theta n to the power of 0, or whether it is omega n to the power of 0 plus epsilon. Right? So since the growth rate of 2 to the power n is more than n, right? It is more than n, so we can say that we are falling in case 3. So when it falls in case 3, we also need to check if Fn is omega of this for some epsilon greater than 0, right? So you can assume any epsilon that is greater than 0, you can even take it as 1, right? So you can say then 2 to the power n is equal to omega of n. And then we also need to check a f n by b should be less than or equal to c of fn for c is less than 1. Then only we can apply this condition, right? So we also check that it should fall, so this is what should happen, that a f n by b, right? So a is 1 here, f n by b, right? F n by b is f n by b. What will be f n by b? It will be 2 to the power of n. Fn is this 2 to the power of n. So n by b is f n by 2. That is 2 to the power of n by 2. Right? So AF n by b should be less than or equal to C of Fn. It should be less than or equal to C of 2 to the power of n. For C is less than 1. We need to check whether this condition satisfies or not. So is this for C is less than 1? So let us take an example that let us say that C is half. Because if half will be in powers of 2, so that simplifies our expression. So if I take C as less than half, C as half, okay. So if I take C as half, this is what I get. So I get 2 to the power n by 2, whether it is less than or equal to half of 2 to the power of n. That is going to be true because the right hand side is now 2 to the power of n minus 1. Right? So it is 2 to the power of n minus 1. So 2 to the power n by 2 is less than n minus 1. So this condition also satisfies. So we say that it is falling in case 3. So then my time complexity Tn is theta of Fn. Right? So my time complexity Tn is theta of Fn is 2 to the power of n. Right? So now let us see. So we have seen two examples. One was falling in case 1, one was falling in case 3. Let us see this example. All of you know what is going to be the answer for this. Okay, so but let us see it. Let us do it and find out whether it is falling in case 2 or not. 2Tn by 2 plus n. So A is 1, A is 2, B is 2 here, and Fn is n, right? And my log n to the power of log A base B is log 2 base 2, that is going to be 1. So that is going to be n to the power of 1. Right? So my question is whether Fn is, so now Fn is n and n to the power of log A base B is also n. So it's an obvious case that is falling in case 2, right? So we asked these three questions that whether Fn is n is this or this. So n is theta of n here, right? So this is an example. So the answer is going to be theta, the time complexity is going to be theta n to the power of log A base B log n, right? So it is going to be theta of n to the power of log A base B, that is n log of n. That is as per the rule, this is going to be the time complexity that you have proved using the recursion tree method, as well as you can prove this by your guess and test method. Okay, there is one more method, students, that is called as substitution method, right? So iterative substitution method. So what we discussed, so we followed the textbook. So as per our textbook, okay, so as per the textbook of Corman, he says that there are three techniques. The first one is called as substitution, but substitution, it calls it substitution, but it is actually also known as guess and test method. Okay, in many other in many other terminology. So under substitution, we actually studied guess and test method. We guessed some solution and then we tested it. Then we discussed recursion tree method, and the third one is master method. Okay, in many other literature, in our second textbook, they say there are four methods. Okay, the first one they call as iterative substitution. So in iterative substitution that we did not discuss, what we do is we keep on substituting n by its lesser value, whatever is given, and we try to see if there is a pattern and if we can make something, some time complexity by seeing the pattern. So that method we'll be discussing tomorrow. Okay, and then the other textbook, as per the other terminologies, there are four methods. One is iterative substitution, as I told you, that we try to find the pattern matching. and then they name it as guess and test method, then recursion tree method and master method. Okay, so you need not get confused. So as per the terminology given by Coleman, substitution method is nothing but the guess and test method. Okay, in other terminologies, iterate, it is called, not exactly called as substitution, it is called as iterative substitution, to when they see the pattern. We'll be discussing that method in the next class tomorrow. Okay, or let us see if we can finish today, we can start with that today itself. Okay, so this was our case 2, right? So now let us say, okay, so we have actually done one example from all the 3 cases. Now let us see and try to identify which case it is going to fall. Okay, so please do it so that you can quickly tell me which case it is going to fall. 16t n by 4 plus factorial of n. So anybody can answer. I can see in here the name of Varna. Varna, I can see Shri Ram, Ashwin. Anybody can answer. Yes.
Ma'am, is it third option?
Which case it is?
Third case.
Third case. Okay. So according to third case, your answer is going to be theta of factorial n, is it? Right?
Yes,
Third
ma'am.
case means answer should be theta of factorial n. Let us see. I forgot. Yesterday I had done it, but today morning I did not revise. So, which case it will fall. Okay. So yes, so here A is 16, okay, B is 4 because it is ATN by B, and Fn is factorial of n. So we will follow the process. N to the power log A base B is n to the power 16 base 4, that is n square, right? So now my question is whether my factorial of n is O of n square, theta of n square, or omega of n square. So obviously it is going to fall in case number 3. So the question is factorial of n is O of n to the power log A base B minus epsilon, or theta of n square, or omega of n to the power of 2 plus epsilon, right? So this will fall in case 3, but then I need to also identify the value of C, whether this is correct or not, right? So this is falling in case 3. So then I have to find out if A F n by B, A 16, F n by B. N by B is F n by B is Fn is factorial of n. F n by B is n by 4 factorial of n by 4 is less than or equal to C of Fn. C of factorial of n for some C which is less than 1. So this condition will come as true. Okay. So again, to identify this, we can take C as half. Why half? Because it is having a multiple of 2. Half, the 2 to the power of minus 1. So if I keep this is what we get. So Cn factorial is going to be, so right hand side is going to be half of factorial of n, right? Half of factorial of n, and here we have 16 n by 4 factorial of n by 4. So obviously this is going to come as true. Okay, because this is going to be greater than factorial n by factorial of n by 2. Okay, so this condition satisfies that we can prove. So then it falls in case 3. So we say that Tn is theta of factorial of n. Okay, so when we are proving something, maybe just by seeing the expression, okay, it so happens that just by seeing the expression, I know the answer. If I have been given options, I know the answer is going to be factorial of n. But when we are applying master method, and we will also know that we are able to find a C which is going to satisfy this inequality. But then we need to prove it. We need to follow the steps. Okay, so Tn is equal to theta of factorial of n. Okay, so let me just tell you one interesting case. Okay, I mean, no, I'm not saying anything about your senior students. What happened last year? Uh, I was taking the same course, right? The class strength was 69 that time. Okay, there were three sections, and so yeah, so these students had opted. So very nice class. Your seniors were also very good. Okay, so we were just doing the, I was teaching like this. How I am teaching to you, the same way I was teaching to them also. Okay, but now the thing is, you people already know that you are going to have an end semester exam, a mid semester exam, and all those stuff. So probably you are taking down notes. Okay, so I was teaching the same way last time also, and but this and it was just the lockdown had just it was the first semester that of the introducing the online exam. So they were not taking it seriously, or maybe they were not making notes. Because it was not decided at that time that what will be the pattern of mid semester exam. Okay, and finally it was decided that the mid semester will be subjective. Okay, so we will be making various sets of question papers, and then you will be given problems, and then it will be they will have to solve and give. Okay, so fine. So that was, so when I came to know, I really did not mind, because I was teaching the way we were doing the classes in the physical medium, right? Only thing is, now the speed is increased, because all this probably, if I was taking classes, I would not have made slides. All these problems I would have done on the whiteboard. So maybe it would have taken more time. Now maybe we could not solve so many problems. I would have solved some problems, and some I would have given for homework. Okay, so nothing. So I was not affected as a teacher when they said that subjective question paper we have to make. Okay, so only thing is, it will take more time for us to correct, but I was not affected. So at the first go, students all got very tensed. Maybe that would have happened with you also, right? So they just told to the higher ups that we were not taught as per, we were taught as if the question is going to be objective wise. Okay, so the students told this to, wherever they could say, they said that we have been taught from the objective perspective. So, okay, they had said, means, there are other repercussions of all that, but later they themselves realized, that it was, that they were wrong. Okay, so they themselves, and, in the other meeting, so what happened is, there was a face-to-face meeting, because they had said something like this. There was a face-to-face meeting, that, okay, where you taught, our teachers teaching as per, the question paper is going to be objective. So then they themselves said that, no, teachers have actually taught us, but we did not take it seriously, because we thought it is going to be objective. So we did not take it seriously. So again, to reiterate why I am sharing this with you is, so when I am teaching, this is not in my mind that whether, you are going to have an objective based paper, or you are going to have a subjective based paper, whether these kind of questions will be asked in the exam or not. No, I'm not, that is not there in my mind. Okay, maybe after doing all this, doing so many proofs, you may be thinking, why should I learn all these proofs? This is not going to be asked in the exam. No, that is not the objective. My objective is, whatever is there in my course, I have to give you a strong foundation. Okay, so after doing all this, if somebody asks you, what can you apply master method, you should know all the three things. When you say it is in case 3, you should know that you need to also check one condition. Okay, so it is like that. Okay, so that is, so when I am teaching, it is not in my mind whether I am going to ask this in the exam or not. Okay, so same thing, students, when you want to learn, you do not keep this in mind. Okay, that why should I do this? Anyways, ma'am will ask objective, or ma'am will ask subjective. It should not matter. Okay, so yeah, so please make notes, students. Take it down in your notebooks, and do not, when you attend the class, do not think about the pattern of exam, because the pattern of exam is very dynamic, right? It can happen. Last time you people faced the issue, right? Suddenly the viva was stopped, and then you had to go through the viva, right? So we really have to be dynamic. Okay, so let us not when we attend classes, let us not think whether I should make notes or not. This will not be asked. She will only ask objective questions, so why should I learn all this? Do not keep it in mind, okay? Because when you write in your profile that you are triple A was your one of the elective course, you must know how to prove something, okay, for your own, okay, so that gives you confidence. All right. All right, students. So this was your third case of master method. Now let us see this one. Okay. So now I think I have motivated you enough that all of you have a pen paper with you. So now let me see who answers first. Which case it is going to fall? Tn equal to under root 2 Tn by 2 plus log n. Whoever gets it first, you can answer. No, it will not take so much time for you.
Third one only, ma'am.
Third one, okay.
Because comparison between log n and root n. So
Okay, okay. So A is under root of 2, B is 2, Fn is log n. So n to the power log A base B is going to be n to the power of log under root 2 base 2. That is going to be under root of n. So it is 2 to the power of half. 2 to the power of half. So it is n to the power of half. So it is under root of n. So now the comparison is this. So is log n O of n to the power of half minus epsilon, theta of n to the power of half, or omega of n to the power of half plus epsilon? Log n. So you said case 3.
It should be case 1, no, ma'am.
Yeah, see, log n will be less than n, for example, if I say, right, log n will grow less than n. So it has to be here. So log n is going to be O of n to the power of, now it is with the power, right? So n to the power of half minus epsilon. Okay, so it is going to fall in case 1. Okay, so we have to see what is log n. So log n, what is the growth rate of log n? Okay, so growth rate of log n is going to be less than n to the power of half minus epsilon. You remember n to the power of half is more than log n. Okay, minus epsilon, if I can find a value of epsilon which is greater than 0. Okay, so this is going to fall in case 1. Okay, it cannot fall in case 3. Okay. So it is, so as per case 1, the answer is going to be theta of n to the power of log A base B, that is theta of under root of n. This is n to the power of log A base B. Okay. Let us see another example. Yes. It looks similar to 2Tn by 2 plus n, right? So, but the answer will be different because here the value of A is different.
Case 1, ma'am.
Case 1, let us see. Okay, A is 4, B is 2, Fn is n, and n to the power log A base B is n square, right? So now the question is n O of n square, theta of n square, or omega of n square plus epsilon? So obviously for epsilon greater than 0, I think we had done this problem before also, if I remember correctly. The first problem probably. Okay, so it is going to fall in case 1. Okay, so it is going to be as per this theta of n log a base b. So it is going to be theta of n square. Theta of n square. That is why it is important that we always keep it ready, n to the power of log a base b. Right? So that is my case 1. Okay, then there are other problems, which I have not solved. Okay, so these 4 problems I have not solved. These 4 problems, either you can please make a note of these 4 problems. Okay, so either we will solve them, we will be solving them in coming lectures. Okay, maybe by iterative substitution or applying the master method itself. Okay, or you can take down these as practice problems. Okay, so there are 4 problems which you can solve. These are from the book itself. Okay, in the book there are many problems, and for some problems they have also given solutions. Okay, so for the problems for which they have given solution, I think their star, they would have put a star. Okay, and many are solved examples as well. Okay, so these are the problems which you can make a note of. Tn is 2tn by 3 plus d. Next one is Tn is equal to 7tn by 7 plus n. Tn is equal to Tn minus 1 plus log n. And Tn is equal to 8tn by 2 plus n cube. We will see them maybe in coming slides. Some of them are there solved in the next slide. Or maybe I think, yes, I think that I have made the tutorial there. I have given the solution for these problems. Okay, after unit 1 we will be doing one tutorial. Okay, so yeah, I think that's it for this recurrence part 1. So I'll start with recurrence part 2. So as I told you, we are going to discuss basically the review, the whatever we have done. Okay, so this is from the first one. Whatever we discussed, part 1 was from our textbook. Okay, so there are other in the literature of algorithm analysis, they generally say that recurrence equations can be solved by 4 methods. Okay, so what Coreman and are they say that there are 3 methods. Yesterday I again opened the textbook, because after a gap of 1 year I had not opened the textbook. So again, while I was seeing the master method, I got little confusion. So I again visited the textbook. So again, the textbook says these 3 methods. Our textbook says first one as substitution method, that we say, though it says substitution method, it is actually about guessing and then proving it by the induction. Guessing and proving it by induction. That is the first method, substitution method. Second method is recursion tree method, and the third method is master method. So as per our textbook, we have completed the 3 methods. But there is other books, or there is other literature that says that recurrence equation can be solved using four ways. First one is called as iterative substitution. Okay, so as I told you, in iterative substitution, so first we get Tn is equal to Tn by 2. Suppose I get Tn is equal to 2Tn by 2. So next time I will right hand side again I will write Tn by 2, again I will open in form of whatever is given. So we keep on substituting, okay, till we are able to find a pattern. Okay, and for that pattern we try to find the complexity. Like that we do it in iterative substitution. We'll be solving 1 or 2 problems from that here. Recursion tree method is same. Guess and test method is what is called as substitution method in our, as per the author Coreman. Okay, that is what we call as guess and test method, and master method is again same. Okay, and towards the end we will also take a classic problem that is called as integer multiplication. Okay, you must be thinking why integer multiplication. So I will talk about it. Okay, I will talk about it, that how to efficiently do this. It's a classical problem, that how to make the integer multiplication simplified. Okay, so we will do this after we do the recurrence. Okay, again we will solve it using recurrence. This is one algorithm that we'll be discussing. Okay, so what is iterative substitution? So this is also called as, it is also called as plug and chuck technique. Okay, we iteratively apply the recurrence equation to itself and see if we can find a pattern. For example, that is what we have applied here, right? So Tn is equal to 2Tn by 2 plus Bn, suppose. Suppose this is the main equation that is given. Tn is equal to 2Tn by 2 plus Bn. So it will be good if you note it down in your notebook and you do it. Okay. Then the next line is going to be, I have kept this 2 here. Tn by 2, I am opening, you see within this parenthesis, I have recursively written Tn by 2 and plus Bn is coming here. So now Tn by 2 is written as 2Tn by 2 means 2Tn by 4 plus Bn means Bn by 2. Okay, so we have replaced n by n with n by 2. So it is, so this Tn by 2 is 2Tn by 4 plus Bn by 2. So now when I open, I get it as 2 square T n by 4. Rather than writing it as n by 4, we are writing is 2 to the power of 2. Because we are seeing a pattern with that. Plus this Bn by 2 will become, this will be multiplied by 2. So this will become Bn. So this Bn plus this Bn becomes 2Bn. So now we rewrite it because we are trying to identify some pattern. Okay, so we are identifying a pattern that Tn was 2Tn by 2 plus Bn. Again, what I got here is I got it as 2 square T n by 2 square plus 2Bn. So one more time, if I do, I will see the pattern that it is nothing but 2 cube T n by 2 cube plus 3Bn. Next time I will get 2 to the power 4T n by 2 to the power 4 plus 4Bn. So finally, I can say that the pattern is 2 to the power of I, if I am in ith iteration, T n divided by 2 to the power of I plus IBN. It is 2Bn, 3Bn, 4Bn, it is going to be IBN. Right? And also, the base case is given. The base case is when Tn is equal to B. Okay, so that is actually given here. The same expression is given here that is missing in the first part. The equation is this: Tn is equal to 2Tn by 2 plus Bn if n is greater than or equal to 2, or it is B if n is less than 2. Okay, so when n is 2, it is this, or when n is less than 2, it is going to be B. Okay, n is less than 2, for let us say when n is 1, Tn is B. That is what is given. Okay, so Tn is equal to B is given as a base case. Okay, so now when this base case will happen, right? For this base case to happen, Tn is equal to B is given. For this base case to happen, I should get here T1, right? If I want to say this should be a base case, and for that the answer should be the base case means I should get Bn. Okay, so I should get T1 here. Okay, it's like what we apply in recursion tree. So to get T1, when will I get T1? I will get T1 when n will be equal to 2 to the power of I. So I will keep on getting like this, right? To n divided by 2 to the power I as the ith iteration. So when I will reach to the last iteration, we don't know which iteration will that be. When I reach to the last iteration, at the end, I am going to get T1. So when will I get T1? When 2 to the power I will be equal to n. So this will be n divided by n. So I will get T1 here. Okay, like that we are going to find the stopping condition. So when 2 to the power I is equal to n. So when 2 to the power I is equal to 1 means I am going to get, I take log both the sides. So I get I log 2 is equal to log n. Log 2 will become 1. So I am going to get I is equal to log n. It is like this now. My aim is to find out the value of I. So when we do recursion tree, what is the aim? The aim is what is going to be the depth. When we do the recursion tree method, we actually find out what is going to be the depth, and we also find out how many number of leaves are there in the last level. Right here, the same way, it's you can have the same strategy here also. I am keep on writing it in terms of I, but I have to stop. The stopping criteria is when this is T1. So when I do this, I get the value of I is equal to log n. So when I is equal to log n, I need not keep on, this recursion will stop. This recurrence will stop. This recursion will stop when I is equal to 1. That is the stopping criteria. When this, I get it as T1. So I get I is equal to log of n. Right? So now if I put it, I is equal to log of n. So what do I get here? So I get here, you just put it here. So 2 to the power I is, see, 2 to the power I is n, right? From this first part, what will I get? So this is my equation actually. Tn is equal to 2 to the power I, Tn by 2 to the power I plus Ibn. Now, when I have to stop, I will consider this as T1. So T1 will be B, right? T1 will be B. So that B has come here. Okay, and 2 to the power I. 2 to the power I is nothing but n. So from the first term, I am getting Bn. Plus IBN. IBN, I have written Bn here and I is nothing but log n. So I get the answer as Tn is equal to Bn plus Bn log n, which is nothing but you will reduce this term. This term is contained in this term. So you will call it as Bn log n. Finally, you will call it as n log n. Finally, this is n log n. Right, so you can understand this iterative substitution is working exactly similar to your recursion tree, right? So let us see the other way to solve it. You know how actually, yeah.
Ma'am, the second line, ma'am, can you explain from the second line how you got 2bn in the third line? Because number
This
of
one.
brackets are not
This
balanced.
one.
Yes,
This
ma'am.
one.
No. Yes, ma'am.
Okay. You just do it with your pen and paper. Now you will come to know. See how this has come. So okay. Let us start from here. This is 2Tn by 2 plus Bn. Okay.
Ma'am, no, it's sorry, ma'am. But
Yeah,
no,
yeah,
that part
yeah, yeah.
understood. In the second line, ma'am, the
No.
number of brackets, they're not balanced. So we can either get 2bn
Okay.
by multiplying 2 by bn and we are
Okay.
neglecting the plus bn outside, or are we considering b
No,
of
no,
n
no.
by 2 as similar to of n and then adding
No,
both
no,
of
no,
them?
no. It is no. See, so maybe there may be a mistake. I have copied it, students. Maybe the parenthesis may be a mistake. So this is nothing but, see, when I say Tn by 2, it is 2T n by 2 square plus Bn by 2. So it is Bn by 2. It is, you can say this is Bn by 2. When it is multiplied by 2, it becomes Bn. Right? So this is not, so this, it is not a function or something. It is just Bn by 2. Right? So it is Bn by 2. Bn by 2 multiplied by 2 will give you Bn. So that Bn plus this Bn becomes 2Bn. Is it clear?
Okay.
Am I audible, students?
Yes, ma'am.
Yeah, yeah. Okay, so it is nothing but, see, this, when you open this 2Tn by 2, you did it 2T. So again, Tn by 2 is 2Tn by 2. 2Tn by 2. So you just did 2Tn by 2 by 2. So it became 2Tn by 4 plus B, you replace n with n by 2. So it is Bn by 2. So now this whole thing is multiplied by this 2. So this Bn by 2, when it is multiplied by 2, you get it as Bn. So you get a Bn from here and plus this Bn. So that's why you got it as 2Bn. Right? So if you see, you know how exactly this iterative substitution comes. Yes?
I just realized I don't think it's like that, ma'am. I don't think you can cancel 2 into b of n by 2. I don't think we can cancel like that, ma'am.
But why? You will cancel. No, you just do it. See, 2Tn by 2 plus Bn. See, what you have done here, this 2 is in the outermost parenthesis, okay? And I think this is, okay, you are saying that, yeah, this parenthesis is extra. This is extra. This one is extra. You know, this closing parenthesis is extra, students. This is a mistake, yes. Right? Do it, no, do it with your pen and paper. It is correct only. 2T, see this 2 is here, this Tn by 2 is 2T n by 2. N by 2 by 2 you can say. So this is 2T n by 4 Okay, you just remove this parenthesis, this is extra, plus bn by 2. It will, no?
Yes, ma'am.
It will. So this parenthesis is extra. Okay, so it is 2t. Is 2t. Okay, so it is 2t n by 2 plus bn, right? 2t n by 2 plus bn, right? So what I am doing is I am saying this tn by 2 I am again writing as 2t. Okay, so the expression is 2t n by 2. Now n by 2 is 2t n by 2. So now n is replaced with n by 2. So it is going to be 2t n by 4, okay, plus bn. So it is bn in the original equation. So it will be now bn by 2, okay, plus bn. Now it is clear? See. So tn by 2 is 2tn by 4 plus bn by 2. You just wrote bn in place of n, you have written n by 2. So now you open it. So it is going to be 4t n by 4. There may be a mistake, students. 4t n by 4 plus, now this 2 will cancel out this 2. Will be 4t n by 4 plus bn, right? So now it is, that's what we are saying. It is 4t n by 4 plus 2bn. Fine?
Yes, ma'am.
Right? Yeah. So it is like that. So now, okay, so this, it's very interesting to know, I was also thinking actually that, why our textbook has not given iterative substitution, So actually iterative substitution is actually, if you see, it is coming, it is one way to find pattern. The same thing we do with recursion tree also. Okay, so just after that, see the same example we have solved using recursion tree. Okay, so recursion tree is like this. So draw the recursion tree for the recurrence relation and look for a pattern. We can do, we can also find the pattern by seeing the recursion tree. In recursion tree also, actually, we are trying to find the pattern. That's what we did while we did the recursion tree. So starting with this, so we are saying this is bn. Like this we start, right? This is bn, and then tn by 2 means tn by 2, tn by 2. So it gives me 2tn by 2. So this is of bn plus 2tn by 2. And then further I am going to, from this n by 2, I will get n by 4, n by 4, n by 4, n by 4. Like that, I will keep on getting. Okay. Now, if I see the size, so, and this is the depth. At depth 0, my, at depth 0, the size is n at this level. At depth 1, the size becomes n by 2. Right? So every level, at every depth, what is the factor of t? I say 2 to the power of I, and the size becomes n divided by 2 to the power of I. Like that, we calculate the depth of the tree. That if I am going towards, so finally, what do I say? I say that if I keep on doing till the depth d, right? So n divided by 2 to the power of d will be equal to 1. Right? That's what we aim at, right? That n divided by 2 to the power of I is going to be 1. Because then I will stop dividing my data. So when I say n divided by 2 to the power of I is equal to 1 means n is equal to 2 to the power of I. That is what we do to find out that till which level we have to explore. And the same thing we did here. In iterative substitution, we did the same thing, that we wanted to find out T1. That's what we do here in recursion tree also. So here we say that the size is n. Every time the size is reduced by n by 2, by half. So the total time, so if it was given to me that if, the pattern was not there and the recursion tree method is given. So what do we do in recursion tree method? So in recursion tree method, you remember yesterday we discussed that we sum the cost of all the levels plus the number of leaves. That's what we do, right? So sum the cost of all the levels. So every level, if you see what is the cost, we call it as Bn. So now if you see this is, and so it is Bn by 2, Bn by 2, this is going to be Bn, this is going to be Bn, right? So at all the levels I have Bn, right? So I'm calling it as the size is Bn. Now here I'm saying it is Bn by 2, Bn by 2, Bn by 2, Bn by 2. So because if you see here also it has come like this, Bn, 2Bn, 3Bn, 4Bn, right? So if, you can say that as, if you do not consider these 2, 3, 4, if you only consider that as Bn, right? If you remove those constant terms, then you can call that roughly, if you say this was Bn, then it became Bn by 2, Bn by 2. Okay, so you sum them up, it becomes Bn. Bn by 4, Bn by 4, Bn by 4, Bn by 4, likewise. So again, the sum comes to Bn, right? So every level, the sum is Bn. And how many levels are there? The number of levels are there is the depth of the tree. Okay, so every level it is Bn and the depth of the tree is log n, right? So it is going to be Bn log n. Bn log n, how? Because every level the cost is Bn and the depth is log n. So it is Bn log n. From where this is coming? Then Bn, from where this is coming? This Bn is coming the number of leaves, right? The last level, what is the cost, you can say, at the last level? We consider the cost at the last level is same as the number of leaves, because we consider that each leaf takes the constant time. So here at the last level also, the number of leaves, how many leaves I am going to get is going to be Bn. Okay, it is going to be Bn. So Bn plus Bn log n, like that I am going to get last level plus all previous levels. So that is going to be Bn plus the previous levels are Bn log n. So I am going to get the same complexity as Bn log n using recursion tree as well. Okay, so that's it. So maybe we will wind up for today, students. So here, so the depth is going to be log n. Depth we will calculate as log n, and number of leaves is going to be Bn. You can calculate that. Number of leaves is going to be Bn. Okay, so so we'll stop for today, students. The next next we are going to take it as guess and test method. We have already done. We will take one more example for guess and test method in tomorrow's class, and then we will come back to after guess and test method, we will come back to master method. Okay, so I just want to ask you one question, students. Okay. Okay, so have you seen this version of master method? It is different than the previous version that we have studied. Okay, it is actually the same version, but it is also written like that. If Fn is, so we said Fn is O, Fn is omega, and the second version was is if Fn is theta of n to the power of log A base B. Here we are saying that if Fn is theta of n to the power log A base B log Kn. Have you seen this version before?
Yes,
If you have not, you have seen.
We had
You have
it.
seen.
I faintly remember.
Okay,
Yes, ma'am.
fine.
Design analysis, like that method and this method was discussed.
Yeah, fine. Actually, they are nothing. They are same methods only, because in the previous method that we had learned from our textbook, we can assume that this k is 0, right? So when you say log, so it is log n to the power k, or it is written as log kn. So if k, the value of k is 0, then it is like our previous master method only. So it is actually same only. So, but sometimes, if you consider the second case like this, it helps. We will discuss that tomorrow. Some examples with this method we will be discussing tomorrow, and probably we will also be able to do the integer multiplication. That is my plan. But again, tomorrow's class I'm not sure, because tomorrow is Wednesday, and we may have some meeting. Okay. Anyways, I will inform you as soon as I come to know. Okay. So we are this NAC inspection is happening on Wednesday, Thursday, and Friday. Thursday, Friday, and Saturday. So we are doing many mock rounds. Like say today also is a mock round. Tomorrow also is a mock round. So it's going to be online only. So I will tell you. Okay, so if we have a class, we will be doing this master method plus integer multiplication. If we don't have a class, I will inform you. Okay, as soon as that will be decided, I will inform you. All right, students. Okay, so thank you very much. Have a good day, students.
Thank you, ma'am.
Thank you,
Thank
ma'am.
you. Thank you, students. Excuse me.